Welcome to CIS 151, C# Programming 2. I'm glad you're here. This course builds directly on what you have learned in your previous C# course. You already know how to write C# code, and that foundation is important, but this course is going to feel different. In your CIS 150 C# class, you wrote programs. In CIS 151, you're going to build software. That distinction matters here, and I'll explain what I mean in just a moment. This is a 3-credit-hour course, and for hybrid, we meet once a week for a lab, but if you are in a standard seated course, you'll meet twice a week. You'll be doing a significant amount of work outside of class through the lecture videos that are presented in Canvas. So let's get into what this course is actually about. So a one-sentence version of the difference between CIS 150 and 151 is that CIS 150 taught you how to write code, and 151 is going to teach you to build software. And I mentioned that earlier, so what's the difference? In 150, you wrote methods, worked with loops and arrays, maybe built some console apps or small GUI-based forms. The focus was on learning the language. In 151, the focus is on how professional software is structured, how the pieces fit together, how data flows between layers, and how you make sure your code actually works. You're going to learn how you collaborate with a team using version control. And there are 4 big topics that we cover this semester. In-tier architecture, which is structuring your application in layers so each part has one job. Databases and Entity Framework Core, connecting to the SQL Server and working with data using Entity Framework. REST APIs, building and consuming web services, which is how virtually every modern application communicates. And unit testing, proving automatically that your code does what you think it does. And every one of these is a skill that employers ask about in interviews. You'll have real experience with all 4 by the end of this semester. So let's dive in and meet Megatravel. This semester, you are a developer at a fictional travel agency called Megatravel. Your job is to build out features in their internal booking application. I want you to think of yourself as a professional developer working on a real code base, not as a student completing assignments. The Megatravel application has 2 projects that work together. We have the Megatravel API, which is our back-end application. This is an ASP.NET Core Web API, and it has controllers that expose HTTP endpoints, a data access layer that talks to a database through Entity Framework, and JavaScript Web Token authentication for logins. You can test it directly in Swagger, which is a UI for testing APIs. The other application is our client, or our front-end application. This is an ASP.NET Core Model View Controller, or MVC application. The thing users actually see and interact with in their web browser, and also allowing for visual components using Bootstrap. It has controllers that handle user actions, Razor views that render the pages, and a service helper class that makes HTTP calls to that API that I discussed earlier. The client never touches the database directly. It always goes through the API, and this separation is intentional, and it's the in-tier architecture concept that we will cover as we begin. So Megatravel has 2 types of users that they have different experiences inside of the application. We have our regular users, sometimes we call them travelers, and they register, they can log in, they can see their profile dashboard, edit their information, view the trips that they have booked, pay for those trips, and cancel trips. These are the features that you'll be building out on the user side of the application. Then we have our agents. These are travel agents who work for the travel agency and manage bookings for clients. They log into a separate dashboard, see all of the trips booked through them, see the contact information for each client. They can view payment status and download their trip data into a CSV file. Different roles, different views, different data, but they share the same underlying database and API. One important thing to notice is users and agents log in through the same login page, but get routed to completely different dashboards. This is how this application works, and we're going to learn more about what's under the hood as we progress through our course. You'll also get experience working with the MegaTravel database. Your starter database comes preloaded and ready to go with your main tables: users, which stores all of the traveler profile information; agent, which stores travel agent data; trip, the central table that connects users to agents through foreign keys and stores all of our trip details; and then trip payment, which we will actually build once we get to the point where we are building out our payment feature. There are also two login tables, user login and agent login. These store credentials separately from the main profile tables, and as we get into our course, you'll learn more about why credentials are separated from profile data when we get to the authentication topics. The short version is that it's for security. We never want passwords to be mixed with general profile data. Our starter database also includes some test data, one test user and one test agent with preset credentials, so you can verify everything is working from day one. So what will you build? There are 9 features over 13 weeks of course content, and I'll walk through these quickly so you can see where we are headed. Feature 0 is where you're probably at right now, just getting set up, cloning the repo, configuring your database connection, and verifying that everything works. Feature 1, we're going to set up our unit testing. This is usually what we will do in the beginning, and we will continue to build tests throughout the course. Features 2 through 8 are actual application features, giving the user the ability to modify their profile, to see booked user data in our agent view, viewing of all trips, payment methodology, downloading, agent payment status, and cancellation of trips. Notice that a lot of these features build on each other. You can't mark a trip paid until that payment table exists. You can't show payment status to agents until the users can create payment records. And this is intentional. The sequence here mirrors how real feature development works. Each feature is small enough to complete in 1 or 2 weeks, but contributes to a larger working application. By week 13, MegaTravel is basically fully functional and allows you to test all the way through. That is the goal. And if you get behind, it is also important to note that you can't just skip features. You will need to go back and make sure that you have previous features working, as they often depend on each other. So let's talk about how a week works in this class. Maybe you've taken a hybrid course before, but the structure of this course is important to understand because it can be different from a traditional lecture class, or it might run a little differently than hybrid courses you've taken previously. We meet once a week for lab. There are no in-person lectures. We might do some code along in lab, but the lecture content you would normally get through a second class period is delivered through videos like this one in Canvas. So here is what a good week looks like and how to structure your time. Before you come to lab, you should check Canvas and watch the lecture video. The video introduces the concept for the week, what it is, why it matters, and how it works in our MegaTravel application. There may be other resources or assigned reading to pay attention to as well. Then in lab, you apply the concept discussed in the video. You build the feature, and I'm there to help, and that is what our lab time is for. If you don't come prepared to lab, you're going to have a very difficult time completing the assignment. When you're done, you test your work. So we will run our unit tests and check that they are passing so that we know our feature is working correctly. When you are finally finished with your work, you'll commit and push up to your repo on our Azure DevOps server. The callout at the bottom is really the important part here. The lecture video is your preparation. If you come to lab without watching it first, you'll spend the first half of lab learning what you were supposed to already know, and then you won't have enough time to build, and you'll have to do it on your own outside of class time. Don't put yourself in that position. It makes this class so much more difficult. There are 6 tools this semester I want you to know about and make sure that nothing feels mysterious. Visual Studio 2026 is the ID that we will be using, and this is where you will write and debug all of your code. If you do not have Visual Studio 2026, or maybe you're running an older version, you'll want to make sure to get that downloaded from the Visual Studio community website, which it's free. .NET 10 is the runtime we are using. This is the platform everything runs on. If you're on your personal machine, make sure you have .NET 10 installed. Windows 11 is going to be a requirement for that, so if you have not updated your computer yet, then this is the time that you need to maybe talk to the PC Repair Clinic if you need help to get your computer updated. We connect to a SQL server, which is hosted on AWS. You don't need to run your own SQL server, but we will need to access the SQL Server Management Studio so you can connect to your database, run SQL, and inspect your data. Hopefully you're familiar with the Azure DevOps server and cisteam.otc.edu for your source control from the previous work that you've completed in your C# 1. Every student has their own personal collection and repo. You probably still have all of the code that you wrote from previous semesters in there, and that is where you will submit your work by pushing your commits. Swagger is a tool built into our API project that lets us test our endpoints directly in the browser without needing a separate tool. MS Test plus Mock are the unit testing frameworks that we will be using, and as we get into week 2 with unit testing, you will get a walkthrough on how to get those set up. So we should maybe be familiar with some of these tools, and we will be fairly proficient by the end of the semester. In the real world, knowing these tools is kind of table stakes for being a .NET developer. I want to close this overview with 5 things I've seen that make the difference between students who do well in this course and students who struggle. First, watch the lecture video before lab. I really cannot stress this enough. Lab time is precious and it's for building. If you haven't seen the concept before you walk in, you're starting from zero in a room full of people who aren't. Second, don't skip understanding the early features. Everything builds on everything else. If you copy-paste your way through the first few weeks without actually understanding what the code is doing, you will hit a wall around week 8 and it will be very hard to recover. Third, ask questions early. If something doesn't click after the video and the lab, come talk to me. Don't wait until the night before a deadline. You can use my office time. You can usually meet me before or after class. We typically have a tutor. Make sure you're using all of your resources so you can be successful. Fourth, use the tests as your spec. When you write a test, we are often thinking about all of the different ways the code could go wrong. When I provide a pre-written test, make sure you're reading it before you write a single line of code. It tells you exactly what your finish line looks like, and then you can work backwards from the test. Fifth, commit often. I see students kind of losing work or losing progress because they didn't commit. Frequent small commitments show me your progress and they're evidence that the work is yours. Also, when you reach out to me for help, if you send that email or that Teams message, I'm going to go look at the code that you've committed so that I can understand the problem you're trying to explain. If you haven't committed your code, you're going to waste a lot of both of our times just in back and forth or I'm going to ask, is this committed? Make sure you're doing that before you reach out. So that's the overview. Let's get started. I'll see you in lab.